And we're off. Chapter 3, Lesson 5. A little mind trap here. If you've seen it before, you got it. If not, maybe you'll figure it out anyway. Did you get it? It's the word unhappy, but it's missing a U, so it's unhappy without you. Today's lesson deals with two angle pairs. Today we're working with complementary angles and supplementary angles, and perhaps you understand those already. Then it will be a review. We'll try to make those concepts a little bit more clear to you. So if you see this picture of a biker racing, it looks like he's got it leaning over pretty well there. What geometric ideas come to mind? Think about that a little. I'll pause and just talk a little bit. Maybe you see these wheels, which you know are circles, but they appear to be ovals. Maybe that's one. Hopefully you see something else going on here. Do you see two rays acting as sides of an angle, which they're naming angle A? If I draw some lines in there, rays, segments, whichever one you call them in this case, and I label some points on them, X, S, R, and Y. Get any other ideas? Oh, I'm thinking back to the last lesson. What can you say about ray YS? Hopefully you're saying that it's between ray YX and ray YR. That would also mean then that angle XYS plus angle SYR equals angle XYR. And the reason for being able to say that is, got it, the betweenness of rays theorem. So if we just take out the background picture and just have the lines in here, we say that angle A and angle B are complementary because together they equal 90 degrees a right angle. So we're suggesting that this is a right angle. Excuse me. And then because they together, when you add them together, they equal 90, they're complementary. So here's our definition of complementary angles. One thing you need to get from this lesson. Two angles are complementary if and only if their sum is 90. And since it's a definition, we could also say if the sum of two angles is 90, they are complementary. Back to this picture, and let's draw some other lines in there. What if we were to draw that in there and that? So slightly different diagram. Angles B and C are no longer complementary because together they equal much more than 90 degrees. Actually, what do they equal when you add them together? Correct. We say that angles B and C are supplementary because together they equal 180 degrees or a straight angle. So our definition here of supplementary, two angles are supplementary if and only if their sum is 180 degrees. Let's use those two ideas as well as some previously learned things to try to do this. Draw a figure like this on your paper. You don't actually have to do that. You can use the picture up there. Label it as shown and don't put in the question marks. Give the degree measure of as many other angles as possible. So I'll pause here just for a minute. Not very long, because without some more information, you really can't do anything on this one. I mean, we know that the sum of angles A, B, and this angle down here at C would have to be 180. But we only have the 50 here, so we can't figure out angle B or this angle ACB. We need more information. So here's some more information. See if this helps. Angle A and angle B are complementary. So this angle up here at angle A and the angle down here at B are complementary. Remember what we just learned that means. And angle DCB this angle down here, and angle B are complementary. So with that in mind, what else can you tell about this picture? How many other angles can you label? Why don't you pause and give that a shot. See how many angles you can label. When you're back, we'll compare. So you're back, and the fact that A and B are complementary means that if this one's 50, this one down here at angle B would have to be 40 degrees to make the sum equal to 90. And then DCB and angle B are also complementary, which means this angle then would have to be 50. Okay. Which, by the way, is actually going to be one of our theorems today, that if you have two angles complementary to the same angle, they have to be equal because they add up to 90. Well, let's keep going. Can we name any other angles? Now that we have 50 up here at angle A and 40 at B, we know that angle at C here has to be 90. Triangle angle sum theorem, and since we already have 50 degrees there, that would mean this one has to be 40 degrees. Do we have enough to finish? Sure we do. 50 and 40 is 90 in triangle DCB. What's left is 90 degrees. Every once in a while it does that. Which on a diagram like this, it's always a good idea to label right angles like that. We could do the same in this one. 50 and 40, what's left is 90. So this one is also 90. You subtract 90 from 180. Which makes sense. Since it is a triangle, this would have to be a straight line. And we've got 90 and 90. So these two angles we would say are, what's the other word we had today? Supplementary, because their sum is 90. So our third theorem of the year is coming up here. No words to it at first. See if you can figure out what it's going to say. Look at those two angles. What are they? Today's lesson. Move that one up out of the way, and I'm going to throw another one in there. What are they? Appears to be the same. So if I slide that one up, you'll notice that those two are exactly the same measure, which only makes sense, doesn't it? Here's our theorem. Complements of the same angle are equal. So because those two are complementary, their sum is 90. And those two are complementary because their sum is 90. Those two have to be equal. In other words, if this was 30, each of those would be 60. If this was 20, each of those would be 70, and so on. So complements of the same angle are equal. Theorem 3, not a hard one. In order to use it, though, we should prove it. See if you can get these steps in here as we go. Try to answer them as we go before I put them on the screen. So our first step, we got to start with the given. It's all we have to work with. So the reason over there is given. All right, what do you think is going to be the next statement we can make if we say that 1 is a complement of 3 and 2 is a complement of 3? Think about what that means, that word complement. And we'd come up with this step. Angle 1 plus angle 3 is 90 degrees, and angle 2 plus angle 3 is 90 degrees. Our reason? If two angles are complementary, their sum is 90. Again, a way we can shorten up our work here a little bit, for this one we could simply say, and I'm okay with abbreviating, definition is DEFN, definition of complementary. Hard to write with my mouse here. Spell that whole thing out at least, okay? I'm not going to right now. All right, so now we've got 1 and 3 are complementary, and we've got them both equal to 90. Keep in mind where we're trying to get to. We're trying to get to angle 1 is equal to angle 2. So we need to somehow, well, look, they're both 90. And if A is equal to B, A can be substituted for B anywhere, so we're going to end up with this. Angle 1 plus angle 3 is equal to angle 2 plus angle 3. They're both 90. So our reason over here on the right, got it? Try to say them to yourself before you hear them. That would be substitution. Okay, so now what? Where are we going next? We're trying to get to angle 1 as angle 2. We're pretty close. Anybody smell it out? Can we go right to the prove step? Angle 1 is angle 2. We can. Compare the left side, compare the right side, and hopefully you see that we subtracted. We subtracted angle 3 from both sides. So we have proven that complements of the same angle are equal. 1 and 2 were complements of 3, and we proved they were equal. Theorem 4, again a little picture choice here. Those two angles appear to be, what's the word? Correct, supplementary. Can you guess what the wording on this one's going to be? Should look similar. Correct, supplements of the same angle are equal. The proof is going to be crazy similar. So you see up at the top there we got angle 3. We're just going to change it to angle 4. What else is going to have to change? Well, instead of the word complements, we need supplements. In the given, they're supplements. So see if you can give the reason to these. 1 and 3 are supplements of 3. 1 plus 3 is 180. 2 plus 3 is 180. Angle 1 plus angle 3 is angle 2 plus angle 3. And angle 1 is equal to angle 2. Do you have those reasons? Pause it. Challenge yourself. See if you can jot them in there or at least say them. So we had given in the first step. We have definition of supplementary. Or in this case, we wrote it out. If two angles are supplementary, their sum is 180. Then we substituted. Step 2 is all we needed. And then we subtracted angle 3 from both sides. So there we go. A little short lesson today. We'll work our way through some of these questions. First of all, he begins with this idea of complement. You've probably heard the word complement a different way. It'd be with an I in there. This is a little different. Complement and supplement are quite similar. Complement is defined as something that completes or makes up a whole. In Genesis, Eve was a complement to Adam, made up a whole. I think that's a good way to think of it. Supplement, in the dictionary, something added to complete a thing or strengthen the whole. To what number does the word whole refer with respect to complementary angles? Something that completes or makes up a whole. What does whole mean there for complementary angles? And then for supplementary angles? And which one would you rather get? I'm taking it into flight again here. A safe angle. I did not know this until I read this. When a plane's going to land, there are landing lights that if you're too high, they appear white. And if you're below it, too low, they look red. So the pilot can tell without maybe looking at his altimeter or any other controls on his dashboard whether he's in the right spot. Safe would be a 3-degree angle. Again, we're looking at a lot of stuff here before you start answering the questions. And here are the questions. If it's approaching the runway at a safe angle, right here it is, what angle does the path make with the vertical? So there's the vertical, there's the plane. They're asking about this angle. What relation then would these two angles, the red one and the one we just mentioned here, what relation would they have to each other? And then two more questions, similar. The plane creates an angle with the runway. What would be that measurement? And what relation do those two angles have? All right, we're going to do a little astrology. He tries to bring in a lot of different features. Obviously, astrology is contrary to the Bible in many ways, most ways probably. But back in history, 12 signs were equal to 360 degrees. By talking about signs, they're talking about Leo and Aries and Gemini and so on. If this fact is given, that 12 signs equal 360, how many degrees would be in one sign? How many degrees would be in the supplement of that sign? In the complement of that sign? Notice you got to go back to 8 each time. And where do you suppose the name sign came from? Don't really care what you put there. I just said from the zodiac signs of astrology. All right. You don't have to actually do a construction here. You just have to sketch something to help you figure this out. Suppose a right angle is bisected and each of the two angles that result is trisected. Got that in your head? Maybe try that before I show you. Right angle is bisected. All I ask you to do is sketch it. And then those two angles are trisected, so we're looking like this. Sketch the figure. Then answer the questions. How large is each of the smallest ones, and what do they have in common? Let's take our angles onto the downhill ski slope. And there's some physics involved here. He's showing you that when somebody's skiing downhill, his weight is a force going downward. The drag would be the wind blowing against him, and it would be slowing him down. But at the same time, the lift would be the wind going underneath and causing him to lift up a little bit. So we've got all these forces going on here. Probably gravity, no, inertia, moving him down the hill. So if we take a protractor and plop it onto this center and put 0 at, where does he want 0? OD as a coordinate of 0. So it's like you put the protractor on and then twist it around. And the other rays are labeled. Draw and label them. So it's going to look something like this. Recall how to read this? Ray OW is between rays OD and OF. And that seems true. Again, why? Because its coordinate, 117, is between 0 and 180. Or 0 is less than 117, which is less than 180. Good old definition of betweenness. They want an equation now. Since it is between, they're looking at the betweenness of rays theorem. So come up with that equation. Once you've done that, use the protractor postulate to calculate some measurements. Angle DOW. Remember the protractor postulate. Positive number differences measure angles. And then once you have those numbers for those angles, talk about the relation that they have to each other, thinking about this particular assignment. Same thing there, and number 20. And then the definitions of acute and obtuse. Apply those and find one of each. Or is it 2 of each? Yeah, I think it's just 1 of each. Ollie and Alice out in the woods. Ollie's wandering around. Takes a long rope. He goes around 3 trees. You picture it? So around 3 trees. And he says to Alice, my 3 angles are supplementary. So he's got some things right. He's connecting the angle measure 180 degrees with supplementary. Triangle angle sum. But he's got something messed up. And Alice says that's ridiculous. She notices it right away. So why is it nonsense when he says the 3 angles were supplementary? Look back at the definition if you need to, or the theorem. Ollie then says, okay, well then 2 of the angles are supplementary. Answer that. Is it possible? Why or why not? But when Alice looked at the triangle, she said that she thought 2 of its angles could be complementary. Is that possible? Thinking about the definition again and explain it. All right, we jump into the hammer throw in track. We do not have this on our team. We have the discus and the shot. I don't know if they do hammer throws in our meets and we just don't have anybody, or whether they don't have it in high school. They're telling us, though, that the vertical, where you'd be standing, and the horizontal along the ground, the best way to release it is this path right here, where OH bisects YOX. Remember what bisect means? To divide into two equal, in this case, angles. So some questions about it. Because OH is between OY and OX, why can we say that angle 1 plus angle 2 equals angle YOX? Flash back to the previous lesson. Hopefully you've got that. If not, take a look back. Given that YOX is a right angle, why can we say angle YOX equals 90 degrees? You can't just say, well, it is. There's got to be a better reason. Look back. Why then can we say that angle 1 plus angle 2 is 90? Well, we see YOX is 90, and we look at 26. 1 plus 2 is YOX. That's close. Use 26 and 27. I think you'll get it. Now, if OH bisects YOX, why would angle 1 equal angle 2? Well, think about what bisect means. I think you'll get that reason. We're looking for definition, postulate, theorem, something that lets us say that. And then go from here, 28, down to 30. We're going to need to use 29 too. Why does it follow that angle 2 plus angle 2 is 90? Or that 2 angle 2's is 90? Well, I see, looking up above here, I see that 1 plus 2 is 90. That's really close to angle 2 plus angle 2 is 90. What's the difference? You got it now, I hope? And then we end up with simplify. Finally, why can we say that angle 2 has to be 45 degrees? Look at this step. Look at what's different on the left side and the right side, and that should get you there. Clock hands. A small child, just learning to tell time, was told she could stay up until the big hand is on the 6th and the little hand is on the 8th. Have you ever heard that before? Remember that from when you were younger? Now you'd be able to say, I ain't going to bed at all then. Why is that? Well, let's see. When would the big hand be at the 6 and the little hand pointing at the 8? Sorry about that, jumping out there again. What time was she supposed to go to bed? Draw a picture of the clock to illustrate it. I kind of did, but my picture isn't quite right. According to the description of the clock, what angle would the hands make if we did what they said right here? If what the child told was true, how is it she might have been able to stay up all night? And finally, what angle would the hands actually make at the indicated bedtime? Hopefully you got that one figured out. Maybe a hint is 6:30. Move on. Little chart here. Suppose that angle C is a complement of A, and that angle S is a supplement of A. Catch this. Copy and complete the table. Well, that shouldn't be too hard. If they're complements and that's 10, this one must be what? Yes. And the supplement? Right. So it shouldn't take much to do that. Now a question, how does S seem to compare with C? Look in each case. What seems to be the case? And if angle A was X, in general terms, make that an X. What's the measure of angle C? What's the measure of angle S in terms of X? And finally, use two expressions in some algebra to show the conclusion suggested by the table is always true. So things you did at 38 and some other algebra. Let's take angles onto a spherical Earth. But we're going to make it more in 2 dimensions here. The Arctic Circle, way up here, 66.54 degrees north of the equator. And the Tropic of Capricorn, we're down here, 23.46 south. So So we're studying the picture here first. What relation do the angles have to each other? So this angle and this angle. Look at the measurements. Think about this lesson. On the first day of winter in North America, the sun is directly overhead at noon on the Tropic of Capricorn. So the sun would be right over here, straight overhead. That's a given. Where do you suppose the sun appears to be at the same time on the Arctic Circle? Where would the sun appear? All right. North and South poles are the points that are 90 north and 90 south. What relation other than being equal do these angles have to each other? So here's the equator. There are the two angles. What relation do they have to each other other than being equal, which we were already told? On the first day of winter in North America, the sun never sets at the South Pole. What do you suppose is true of the first day of winter at the North Pole? Okay, thinking that through along with maybe some of your geography. New picture, we've got 1 and 2 are complements of AOC. That's interesting. Kind of points out something that's important, that two angles don't have to be touching or sharing any sides to be complementary. All that has to be true is that the measure of their angles is 90 degrees. So we're told here that angle 1 is a complement of angle AOC. So maybe this could be 10 degrees, which would make angle AOC 80 degrees. Angle 2 is a complement of AOC. Well, then again, if that were 10, then AOC would be 80. What else seems to be true after you look at these givens up here? 1 and 2 are complements of AOC. What else seems to be true? Explain that, why that is. And is it possible to figure out the size of each angle in the figure without measuring them? Explain. If you say yes, give the measurement. If you say no, explain why you can't. I mentioned earlier this was coming up. Write the proof of Theorem 3, or of Theorem 4, I'm sorry, using the plan that we used in our lesson on Theorem 3. So spoiler, I'm going to give it to you here, but I'd really like you to try it first, see what you can come up with. So pause it, give it a shot, and come back. So you're back. I hope you left and tried it. So first step, you've got to start with our givens. So 1 and 2 are supplements of angle 3, and of course the reason would be given. Next, well, if 1 is a supplement of 3, what statement could we write? Well, we could say angle 1 plus angle 3 is 180 degrees. Same is true of angles 2 and 3. And that would simply be what? Correct, the definition of supplementary angles. Or written out in words, if two angles are supplementary, their sum is 180. Where are we going next? Do you remember the other proof? If they're both equal to 180, what can we do? We can set them equal. We're just substituting. Step 2. And then trying to get to angle 1 is angle 2. I look at the left side, looks like there's just an angle 3 on both. So we'll substitute to get to our proof. Really like our set 3 today. 15 squares, that's important. Don't let that slip by you. There are 15 squares in the picture. From the appearance of the figure, how large do you think the angles at the points of the stars are? Show your reasoning. Can you figure out how many degrees are in the points of the stars? So that'll do it for this lesson.